we are gonna start off with the chapter hydrogen, which is one of the easiest chapters which you will come across during this whole journey of all the competitive exams after classes 11 and 12. So without wasting much time, let's get started with the video. So hydrogen, this element is said to be one of the most abundant element in the universe and the third most abundant element on the globe. The first most abundant element in the universe and the third most abundant element on the globe surface. It is said that in future it will be the major source of energy. Okay. This word hydrogen is derived from two Greek words, one is hydro and one is genus. Okay. Hydro means water and genus means forming. So hydrogen is basically meant to be water forming. Okay. The element hydrogen means water forming element. It forms one of the most number of compounds than any element. Okay. The atomic form of hydrogen has one proton and one electron respectively, and in elemental form it is in the diatomic state, which is H2 molecule. It is represented as H2. Now we'll be discussing the position of hydrogen in the periodic table. This has been a matter of debate for quite a long time. Currently, it is the first element placed in the periodic table. If you look at the periodic table, hydrogen will be the first element on the left hand side, topmost left hand corner. The electronic configuration is 1s1. So this resembles two kinds of elements. One is the alkali metals and one is the halogens. The outer electronic configuration of alkali metals is ns1. And look at that of hydrogen, it is 1s1. So it resembles. And alkali metals is the first group of the periodic table. So according to this, hydrogen should be placed in the first group of the periodic table. Similarly, for halogens, the electronic configuration is ns2np5. It is short by one electron corresponding to the noble gas configuration. This is also short by one electron corresponding to the noble gas configuration of helium, He2. Okay, and this is short by one electron corresponding to the noble gas configuration other than helium. Okay, and these are placed in group 17. So according to this, hydrogen should be placed in group 17, and according to this, hydrogen should be placed in group number 1 of the periodic table. Therefore, hydrogen resembles alkali metals which lose one electron to form uni-positive ions, as well as halogens which gain one electron to form uni-negative ions. Okay. Hydrogen forms oxides, halides, sulfides like alkali metals, but has very high ionization enthalpy, which is unlike to the alkali metals. Okay, alkali metals have low ionization enthalpy, not this high. And under normal conditions, hydrogen do not possess metallic characteristics. So these are the points where hydrogen differs from alkali metal characteristics. Isotopes of hydrogen. Hydrogen has three distinct isotopes. One is named protium, one is named deuterium, and the other is named as tritium. Protium is denoted as H11, one proton, one electron. Deuterium is denoted as H21, and it is also denoted as D. Tritium is denoted as H31 and it is also denoted as T. Okay. Protium has 0 neutrons, as you can see the difference between proton and electron. Deuterium has 1 neutron and tritium has 2 neutrons. Terrestrial hydrogen contains 0.0156% of deuterium in the form of HD. Radioactive tritium is the only radioactive isotope of hydrogen. It emits low energy beta particles, and its half life, T half means half life, okay? Half life. Half life of tritium is 12.33 years. Its concentration is 1 atom per 10 to the power 18 atoms of protium. The isotopes have same electronic configuration and therefore almost same chemical properties. There is almost no difference between the chemical properties of the three isotopes. The only difference is in the rate of reaction, which is mainly due to different enthalpy of bond dissociation. Okay. However, in physical properties, these isotopes differ due to large mass differences. I will be attaching a table where all the different properties such as enthalpy of bond dissociation and mass of the isotopes have been mentioned. You can just go through the table once. Similarly, in terms of ionization enthalpy, it resembles more with the halogens. As I already said, it has very high ionization enthalpy, which is quite a difference with respect to the alkali metals. The You can see the ionization enthalpy of lithium is 520 kilojoule per mole, and the ionization enthalpy of fluorine is 1680 kilojoule per mole, while the ionization enthalpy of hydrogen is 1312 kilojoule per mole, 1312 kilojoule per mole. Okay, so this is quite high, but quite low with respect to fluorine, which is a halogen. So approximately a difference of 500 with this. Okay, today we'll be looking into the preparation of hydrogen, laboratory preparation of hydrogen and commercial production of hydrogen, two methods respectively. Laboratory preparation of hydrogen has two methods. First is reaction of granulated zinc with dilute hydrochloric acid. This is the reaction. Zn plus 2HCl gives ZnCl2 plus hydrogen dihydrogen in the form of gas. Reaction of zinc with aqueous alkali is the second method. Zn plus 2 NaOH gives Na2ZnO2 plus hydrogen in the form of gas. This arrow means gas. This is known as sodium zincate. Now we come to the commercial production of hydrogen. The first method is electrolysis of acidified water using platinum electrodes. This is PT means platinum. Platinum electrodes gives H2, which is dihydrogen. 2H2O in the form of liquid in the process of electrolysis with traces of acid or base gives 2H2 in the form of gas plus oxygen in the form of gas. Second method is preparation of highly pure hydrogen, 99 greater than 99.95 percentage. This might come as a question that what is used in the preparation of highly pure hydrogen. We use barium hydroxide solution, BaOH whole twice solution in the presence of nickel electrodes. There are two nickel electrodes and there is the presence of BaOH whole twice solution, and then what we get is dihydrogen by the process of electrolysis. Thirdly, it is obtained as a byproduct in NaOH and Cl2. In NaOH and Cl2 manufacture by electrolysis of brine solution. Brine solution is NaCl. Okay. NaCl solution is also known as brine solution. So in the manufacture of NaOH and Cl2 using by the electrolysis of brine solution, we get hydrogen as a byproduct. Okay, it is not the main product which we are aiming at for production, but it is obtained as a byproduct. The reaction at anode and the reaction at cathode are mentioned, okay, and the overall reaction is also mentioned, okay. 2Na plus in aqueous form plus Cl minus in aqueous form plus 2 water in the form of liquid gives Cl2, which is gas, H2 hydrogen, which is in the form of gas, Na plus in aqueous state, and 2OH minus in aqueous state. Now we'll be looking into one of the most important methods of preparation of dihydrogen, which is by the method of Bosch process. The pronunciation is Bosch, but the spelling is BOSCH. What we basically do is we take CO plus dihydrogen both in the form of gas, which is also known as water gas and also called as syngas, which will come to later. Why is it known as syngas? So what we do is we take water gas and mix it with twice the volume of steam, and the mixture is passed over ferric oxide and chromium oxide, which are present as catalyst. CO gets oxidized into carbon dioxide, okay. Look at the reaction. Carbon monoxide plus dihydrogen plus in steam, all in the form of gas, in presence of ferric oxide and chromium oxide as catalyst at 673 Kelvin, which is quite a high temperature, gives CO2, which is carbon dioxide, and dihydrogen in the form of gas. This reaction is also known as water gas shift reaction. How is CO2 and dihydrogen removed from the solution, because both are present in the final mixture? What we do is, look, in this vessel we have water, okay, which is in the form of liquid, so it is at the base, and we have CO2 and dihydrogen, which are gases, so above this. Under pressure, carbon dioxide is heavier and hence get dissolved in water. So at 20 to 25 atmosphere, carbon dioxide gets dissolved in water and H2 is separated and hence is collected. Okay. Another method, what we do is CO2 is removed by scrubbing with sodium arsenide solution. Okay. So this is Bosch process, which is very important method of production of dihydrogen. Another method is by oxidation of hydrocarbons. The principle is reaction of hydrocarbon or coke at high temperature in the presence of catalyst yields hydrogen. The general reaction is CnH2n plus 2 plus NH2O at 1270 Kelvin in the presence of nickel catalyst gives NCO plus 2n plus 1 H2. We take N equal to 1 and CH4 plus water at 1270 Kelvin in presence of nickel as catalyst gives CO N equal to 1 plus 3H2O. If we put N equal to 1, 2 plus 1 equal to 3, therefore 3H2. Syngas. CO plus H2 is also known as water gas, as I mentioned in Bosch process, and here it is known as syngas or synthesis gas because it is used in the synthesis of methanol and a number of hydrocarbons. Okay, so this method is also important. The next process we look at is known as the Lane's process. Okay, so dihydrogen is extracted from steam by the method of Lane's process, where what we do is superheated steam is passed over iron fillings heated to 1023 to 1700 Kelvin. Okay, very high temperature. It is because we pass steam over iron. Okay, what we get is ferrous oxide plus dihydrogen. This is all for today. Thank you. Do like, share, and comment, and subscribe to our channel.